The symbol for proton, I like to use a P with a plus, something massive, which is our nucleus. The mass of the electrons is insignificant, but the electrons give most of the volume of an atom. So the first thing we need to do is establish a new mass unit. Because atoms are so tiny and their little particles that make them up are so tiny, we need a new unit that is much smaller than a gram. So a new unit was developed called the atomic mass unit, the AMU. I know it's not very creative, but anyway, it makes a lot of sense. So if you were to take one carbon-12 atom and put it on a little tiny balance that read in AMUs, that atom would weigh 12 AMUs. So an AMU is 1/12 the mass of a carbon-12 atom. But in more reasonable terms, it's the mass of a proton, which I'm sure you've heard of. So now that we have that unit, let's talk about the particles. So this little chart describes the particles that you already know all about. But you need to know this chart on really a different level in chemistry. So first thing we need to know is the two particles that are found in the nucleus. That's the proton and the neutron. The symbol for proton, I like to use a P with a plus. The neutron, because it's neutral, you can put a little 0 there for the charge. It's electrically neutral. But the charge of a proton is not just positive, it's +1. Because notice how the electron is -1. They have the exact same charge, but the opposite sign, and that will be significant as we talk about atoms in the future. Now, the mass of the proton and the neutron are the same. Notice they're about 1 AMU. So if I have a little nucleus over here, I can add up the mass of this nucleus. I've got 7 particles, so that's about 7 AMUs in that nucleus. Now, you say, where on the picture are the electrons? You remember how when you first saw the structure of an atom, you saw these little circuits like that, when you thought that electrons, I used to think that electrons just went around and around and around. It's really not the case anymore. That scale model is kind of ridiculous. If you were to draw a properly scaled atom, the electrons would be nowhere near the nucleus. So here's the illustration I like to use. This is a college football stadium. Put your favorite college right there in the middle. There's the outside of the stadium. Let's put our little nucleus right there. There's my nucleus of an atom. If you were to scale a nucleus down and put it maybe the size of an ant right there in the center of the stadium, where would the electrons be? They're really far away. They're going to be way out here on the perimeter of the stadium. This is where people are coming in and walking around. So can you see how large the atom is relative to the size of the nucleus? But for the sake of this little illustration, I'll throw a couple electrons out here around that nucleus. Now, what is the mass of an electron? I have approximately 0. Of course, it has a mass. It's very small. It's a tiny particle, much, much less than 1 AMU. It's about a 2,000th of an AMU. So for the sake of an atom, it adds insignificant mass. So there is a good illustration of the structure of an atom. Now, how did we learn about this? These things are so small, you can't see them. So I like to relate it to shaking a box. And this is a little illustration I do in my classroom. I take a box and I throw some objects in there, like a quarter, a rubber band, a tennis ball, and, a marshmallow or something like that. Maybe a marble. And I give the box to students and say, shake it up and tell me what you think is in there. And as they listen and feel, they start to describe the properties of what's inside the box because they can hear it and feel it, even though they can't see it. So that's kind of like what happened in about the 1800s. Scientists started to think about things that they already knew and could observe about nature and started to describe these particles. So one of the big discoveries was the electron, and J.J. Thomson used this cathode ray experiments. Cathode rays are just streams of electrons, and he found that that stream was attracted to a positive plate and repelled by a negative plate. And so he learned that those are negatively charged particles. And then Rutherford did this very cool experiment. He took some gold foil and smashed it out into like a really thin sheet. There was only a couple atoms thick. And then he fired some very tiny particles at that foil and found that most of the particles went through, indicating that, yeah, the theory was correct, that most of the atom was empty space. But every once in a while, a particle was rejected as if it hit something. And so this is where the nuclear theory came. And he thought, well, when these particles get rejected, it hits something massive, which is our nucleus. And so this is the theory, how we know that the nucleus of an atom contains the mass. So what are the big ideas that you need to know about the structure of an atom? First of all, where is the mass? It's in the nucleus. The protons and the neutrons are relatively all of the mass of an atom. The mass of the electrons is insignificant, but the electrons give most of the volume of an atom, okay? Because most of the volume of an atom is empty space. I hope this helps, gives you a little illustration and a really good mental picture of the structure of an atom. Great job.